Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam LTAM, long-term actuarial models. An insurer issues a special semi-continuous 5-year term insurance to 60-year-old. The policy benefits are $100,000 immediately on death from natural causes, that's decrement 1, and $200,000 immediately on death from other causes, that's decrement 2. Premiums of $7,000 per year are payable annually. You are given that, this is a typo, my apologies, that mu, the force of mortality due to decrement 1, cause 1, is 5% for t between 0 and 4, and the force of mortality due to cause 2 or decrement 2 is 1% for cause 2, and decrement 2, and the force of interest is 2%. Calculate the reserve at the end of the first year. Now notice that we have these forces only for t between 0 and 4. The insurance was issued to a 60-year-old, but this is for 61 and older. However, we're calculating the reserve at the end of the first year when the person is 61. So it's all good. It's all consistent. And we have it only for 4 years, but the policy is a 5-year term insurance. So for a 61-year-old, there's only 4 years remaining of coverage. And here's the solution. So the reserve is going to be the actuarial present value of future benefits minus actuarial present value of future premiums. The benefits for death from cause 1, $100,000, and they are paid as insurance over 4 years on 61-year-old. At that time, it's only 4 years remaining when the person is 61, and it's for transition from state 0 to state 1, or death from cause 1, plus $200,000 for death from cause 2, which is transition from state 0 to state 2, if we call the state of being alive 0, and dying from decrement 1, state 1, and dying from decrement 2, state 2. And minus 7,000 A.61 angle 4. You could write this also as 0, 0 in the superscript, meaning that this is paid as long as the person remains in state 0. But we don't really have to, because it's self-explanatory what we mean here. And then we need to calculate the cost of those benefits. Well, the cost of the death benefit due to cause 1 is the integral from 0 to 4 e to the minus 0.02, that's a present value factor, times the probability of remaining in state 0 until the force of mortality due to cause 1 gets you at time t exactly, and that's added up over all times from 0 to 4. And this becomes the integral from 0 to 4 of e to the minus 0.02 times e to the minus 0.06. That's the probability of survival of death from both causes. That's why we add the 0.05 and 0.01 to get 0.06. So it's e to the minus 0.06 t times 0.05 dt. 0.05 is the force of mortality, or force of decrement due to cause 1 or decrement 1. Well, if you factor out 0.05, this is exactly A bar angle 4, with force of interest being not 2% as is given in this problem, but instead take it to be 8%, and that formula becomes exactly what A bar angle 4 at 8% is. So that's 0.05 times 1 minus e to the minus 0.32, 4 times 0.08, divided by 0.08, and that's approximately 0.17115685. for the, again typo, my apologies, this is cause 2, so this is 2. So for death from cause 2, we have similar formula, but we can just observe that it's all the same except the force of decrement 1 is 0.05, force of decrement 2 is 0.01. So this is actually exactly 1/5 of this number. So you don't have to do any calculation. You can just take this and divide it by 5, and you'll get this. And then what is A double dot 61 colon angle 4? Well, it's 1 plus probability of survival, discounted at 2%, the same for 2 years and for 3 years, and time 3 is the beginning of the 4th year. So this becomes 1 plus e to the minus 0.06 over e to the 0.02, discounting at 2%. Survival of 2 years, that's survival of over 1 year is e to the minus 0.06, probability of that, and this is constant force, so over 2 years it's just this squared, over 3 years it's this, the same cubed. Then we calculate this and we get approximately 3.561888. And the reserve is what we wrote at the beginning, actuarial present value of future benefits minus actuarial present value of future premiums, but now we have all these actuarial present values used in the calculation calculated. We plug them in and we get the answer, and it's approximately negative 971.26, which is a strange answer, but that's the answer. And that's answer E. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.